This is the video to help with A.SSE.3a. This is the standard about use. It says use the structure of an expression to rewrite it. And for us in this class, that means that we are factoring higher degree polynomials. So I literally took this thing inside this box here. I took this and I copied it from another standard. So if you haven't seen this because you haven't done the other standard or haven't watched the video, this is the one. Let me just show you. It comes from this one, the APR Unit 3, about proving polynomial identities and use them to describe numerical relationships. So this is what it comes from. It's the same concept though. So we are just going to rewrite expressions with them. So things that you're going to have to remember from this. Let me zoom in on it here. We have perfect squared trinomials, meaning that you have something like a plus b. It's in the form of a plus b or a subtract b, and we square it. So if we add them, so then let's just look at some things about this structure, because that's what we're talking about, is using the structure to rewrite things. So notice that this had adding, whoops, that was not supposed to be there. Okay, let's change this to, so we have adding here, so everything in here is adding. But this one has subtracting, so we have subtracting. Then we also have perfect cubes. And notice that we have two things, a binomial, that means 2. We square it and we got 3 terms. Here we have a cube, again, a binomial that we cube, and we have 4 terms. So it follows this pattern, where there's the first thing we have let me go here. So we have the first thing, like whatever the A is, we cube it. Whatever this one, there's a 3 next to it, and we keep on going and look like that. So we can go back and forth. So what we're doing with this lesson technically is we are going from things that look like this, or in fact, more specifically, we're factoring it. So we're going from things that look like the stuff on the right and going back to like the a squared plus b, we subtract b squared. This is something called the difference of squares. It's an important thing in math and an important thing in this lesson. So the difference of squares is very nice. We're going to use that a lot, and you can use that a lot. We also have the difference of cubes and the sum of cubes. So the sum of cubes is supposed to have, let me wait for that to go. The sum of cubes is supposed to have a plus sign right there. And so if we had 2 things that were cubed and we needed to factor them, like one thing cubed plus another thing cubed, it would factor out to be this pattern. So we just have to figure out what the a alone is, not a cubed, and what b alone is, not b cubed. And then we plug them into the a's here, and then the b's. Same thing with the difference of cubes. Yep, so these are actually the main things that we use for this one, is factoring. It's going from back and forth, basically, going from the stuff on the left out to the factors on the right. And yeah, okay, so here are our examples. So that was the main part of the lesson. What we are doing from here on out is just examples that come from either the workbook, the checkpoints, but are questions that are similar to the ones on the assessment itself. So here we have 81x to the 4th. Subtract 16y to the 4th. If you're like me, you're like, okay, I kind of understood the stuff that you talked about, Ms. Q, but nowhere on here does it talk about anything to the power of 4. So I hate, maybe you don't hate me, but maybe you're not happy with me. So let's go through and figure out what to do. So if I said that I know I'm going to take this difference of, I'm going to treat this like a difference of squares, which we say we have a squared subtract b squared factors out to be a plus b multiplied by a subtract b. Let me make sure that I wrote that the same. See, I had a subtract b first, but since they're the same factor, it doesn't matter which one you put first. So now all we have to do is figure out which is which. This is my a squared, and this right here is my b squared. And I can check and make sure that I can do this because this exponent right there is a multiple of 2. So notice we have 2 right here and 2 right here. And as long as that's a multiple of 2, this will work. And we also have to make sure that we can just take a regular square root of those things. So, yeah, so let's go like this. We can say that, but we know that a squared is equal to 81x to the fourth. So if we want just regular a, taking the square root of this, we could say that we would have a is equal to, let's see, the square root of 81 is 9, right, because 9 multiplied by 9 is 81. And the square root of x to the fourth is x squared. Okay, we can do that. And then we can say that b squared is equal to 16y to the fourth. Again, we're going to take the square root of both sides. So then b would equal square root of 16 is 4. Square root of y squared. Y to the fourth is y squared. So now we can plug those back into this formula. So we have one parentheses where our a, instead of a, we're going to write 9x squared plus, and then here's our b, 4y squared, and then 9x squared subtract 4y squared. Now, you would think, oh good, we're almost done, but this is why I'm showing you this, because this one, sometimes when you're done with these things, you can keep on going. This second part right here, we can keep going. Right? We can keep going. Keep going. So with this one, we could say that the a is equal to 9x squared on this one, and then the b is equal to 4y squared. So that would mean a squared and b squared equals that. And then so then a would just be square root of minus 3. Square root of x squared is x. And then regular b would be 2y. So the first part stays the same. That first factor is 9x squared plus 4y squared. And then we're going to put that in that same pattern that we had up there. We're going to put these in this same pattern that we had up there. So we're going to have 3x plus 2y multiplied by 3x subtract 2y. So as long as these three factors, we have three of them. So we have this factor and this factor and this factor. As long as we have those three factors there, it doesn't matter the order, we are now done. We can't factor it anymore. All right, take a big breath. You can stop, rewind this if you need to. So now we're going to do this one. This one also follows one of those patterns that we have above. So let's just look at this. So first of all, I look at the first and last term of this. Let's do it in red. I can see that this, if I said that a squared was equal to 9x to the fourth, then I could see that a would be 3x squared. And then if I said that b was equal to 25, b squared is equal to 25, then b is equal to 5. Now let's look and see which one had that type of pattern. If I look at this perfect square trinomial thing up here, see this one? This follows that. So let's just check. Is this part right here, we want it to be 2ab. We want 2ab. So let's try 2 multiplied by 3x squared multiplied by 5. Is that indeed 30? So let's see, 2 multiplied by 3 is 6 multiplied by 5x squared, and that is indeed 30x squared. So that means that if we go back to this pattern, it's this part right here, this stuff right here that we want. That's what it's going to factor into being. So we can write that. This is going to be the a, which is 3x squared, plus the b, which is just 5 squared. That's it. That's that factored completely. Another way that you can do these is notice this very last one. this, I mean, not this last one, but this one right here. This one's different than the other ones that we can do. So one of the great ways that we can do things is we do it by grouping. Here. So grouping says that you take the first two, or you just take some and you just group it together and you see what's the biggest thing that can come out of both things. And let's see if it's the same. So out of 3x to the fourth, 15x to the third, they both have, let's see, they both have a 3 in them, right? And then the highest x is going to be x cubed. That looks good. And what's left is going to be just an x and then plus 5. That worked nice. And then this one is, I can see it from 6 and 18, I can see a 6 and an x comes out of both of those. And I'd be left with x plus 3. I should pause here. I'm resuming recording because I realized that because I got to pick the numbers for these things, I took questions similar to the ones in the lesson or on the exam. I changed the numbers and I realized that was not the best choice. I had to change one of my numbers. This is going to change everything. So there are steps actually that they recommend for doing that. And step 1 is you want to see if you can take out a GCF out of all. So we're going to look in all of these terms and see if there's anything that they all have in common. So I can see that between 3, 15, 6, and 30, they all have a 3 that goes into them. I can also, I'm taking it out of all, so I'm going to leave that as the green one, I guess. I'm looking at the whole thing. I can see that 3 goes into all of them and also x. So then I would be left with x to the third plus 5x squared plus 2x plus 10. That. Then the next step is like I started last time, is you're going to group. I'm going to look at these first two and those second two. And yeah. Then we're going to group. So the first two and the last two. So I can then look at for the GCF of each of those. Group and the GCF. We still have our 3x, it stays there. And I can see out of these first two, the thing that they both share is an x squared. And what I'm left with is x plus 5. And then out of these two, I can see that they both share a 2. And what I'm left with is x plus 5. This is turning out really well. And from both of them, you can see that they both have x plus 5 and x plus 5. So that means I can rewrite this as that the 3x is going to stay there. And then I can have x plus 5 because that was the same on both of them. Right? Because that, I'm just going to highlight that so you can see that's where that one went. And then these terms that were in the front, right here, of what we took out, that becomes the last parentheses. So x squared plus 2. That came from those things. Right? So that's the last way. That was actually, yeah. So that's the last of those things. Those are the 3 main ways of looking at things. But I feel like it's helpful to keep on going, so I'm going to keep on going. So here we have 125x cubed plus 8x. So the first thing we need to do on all of these, hold on, pausing. Saw an error in what I wrote down, so I had to come back to it. Okay, if we had this 125 x to the fourth plus 8x, we're going to do kind of the same thing as everything. Is we're always going to look for all these, look for a GCF that goes into everything. I can see that there's an x, at least one x in both of those. So it's going to be x multiplied by 125 x to the third plus 8. One thing that would be very handy for you to remember, so let's figure out a nice place to write this down. I'm going to write this in black, and I just want to put down cubes. because it will help you remember. I know that 1 cubed is 1. 2 cubed means 2 multiplied by 2, which is 4, multiplied by 2, which is 8. 3 cubed is 3 multiplied by 3, which is 9, multiplied by 3 is 27. 4 cubed is 4 times 4, which is 16, multiplied by 4 is 64. 5 cubed is 5 times 5, which is 25, multiplied by 5 again is 125. 6 cubed is 6 times 6, which is 36, multiplied by 6 again is something I don't remember off the top of my head. I should know this. 216. 7 cubed is 243, which I remember that from other things. Let me just double check. Yeah, 343. Okay. Anyway, so those are some common cubes. You can keep on making this list if you want to, but I'm just going to stop there. But that helps me so that when I'm down on problems like this, I can see, hey, 125, if I said that this was a cubed, because it looks like this one to me, the sum of cubes looks like this one right here. And I know that a cubed, if that's a cubed, is 125x cubed, then a would be 5x. And if this right here is b cubed, is 8, then b would be equal to 2. So because I have that a is 5x and b is 2, I can use that pattern that says that a plus b cubed is a plus b multiplied by, wait. Yeah, let's go to the top here. This one. A cubed plus b cubed is equal to a plus b. Yep, see, there we go. That's why we have notes. That's a cubed plus b cubed is equal to a plus b multiplied by a squared. Subtract ab, add b squared. So we're going to plug those in. So the 5x is going to go in for the a, and the 2 is going to go in for the b. So it'll be 5x plus 2. Let me show you the colors just in case. We have 5x. 5x is going to go there. 5x is going to go there. 5x. And then 2 is going to go in all those other places, right? So we have 2 here, 2 here, 2 here. So 5x plus 2 multiplied by 5x squared, subtract 5x multiplied by 2 plus 2 squared. And now it's just simplifying that. So our 5x squared stays in the front. 5x plus 2. And 5x squared is 25x squared. Negative 5 times 2 is negative 10x. And then 2 squared is 4. Okay. So I used the sum of cubes to do that one. This one I think is a really weird looking one, where we have a fraction. And you might think, oh no, I have a fraction. And if you have a fraction, then fear not, things will all work out. So let me first of all go back to our list of cubes, because we have 512 and 729. We didn't get that far. So let's go further in our list of cubes. 8 cubed. 8 cubed. There we go, it's 512. And then 9 cubed is 729. Okay, let's go back here. So I know that this is the same thing as 8 cubed, and this is the same thing as 9 cubed. So it's going to follow this pattern, the difference of cubes. It's going to follow this pattern that says right there, the difference of cubes. So it's going to follow the pattern. A cubed subtract b cubed is equal to a plus b multiplied by a squared plus ab plus b squared. Actually, I think this is supposed to be, double check. Yep, the subtract is supposed to be on this first term. Why do we have notes again? Okay, so we're going to plug that in. I can see that I can see that if a cubed is equal to x cubed, then a is equal to x. That's pretty easy. And if b cubed is equal to 512 over 729, then I know that b is equal to 8 over 9. And then I just plug those in. So we have x subtract 8 ninths. Plugging it into this thing right here. Got that part. Now we're going to do a squared, so that's just plain x squared. Plus the a was 8 ninths. And b, or x, I mean. And then b squared, so 8 squared. I'm going to put here 8 squared is 64. And 9 squared is 81. So 64, 81. There we go. That is the factor form. This one is going to follow a pattern kind of like the first one that we did. So I can see that the a squared, so this is the squares, like it's the difference of squares. Like the one below, so like this one right here. So it's going to follow that pattern. So a squared is equal to b to the fourth. Kind of weird and confusing. And then b squared is equal to 81 cubed to the fourth. And a would be b. That's not confusing. And then b would be 9 cubed. I mean b squared. 9 cubed squared. I'm going to put it in that thing, like the difference of squares. Oh, right here. This is this one. The a subtract b and a plus b. So we're going to put it in that one. So and we're going to put it into a subtract b multiplied by a plus b. So our a was b to the b squared, and our regular b was 9 q squared. And then a again was b squared plus 9 q squared. But then we can keep on going on this one, on this part, because it's another difference of squares. So then the square root of 9 is 3. So then it's going to become, it's going to split into two of them. It'll be b subtract 3q and 3 plus, I mean b plus 3q. Multiplied by b squared plus 9q squared. Okay, so that's the factor form of that one. And the last one I'll do is like this. So this one, we're going to look again for that greatest common factor. What's the biggest thing that can go into both of those? Well, I can see that they both have a 3 and they both have an n. So if I factor out a 3n out of both things, I'm left with m cubed subtract 1. Well, m cubed subtract 1 follows the difference of cubes form. So I'm going to write that down here. So that's a cubed subtract b cubed is equal to a subtract b divided by a squared plus ab plus b squared. I'm going to follow that pattern. So we're still going to have our 3n. And then I can see that if my a cubed is m cubed, then a is just m. So it's going to be m subtract 1 multiplied by m squared, because this cube root of 1 is 1. M squared plus m. I can put 1m here if I want to. I don't need that, plus 1. So I'm going to take out that dotted line actually. And that's that. So those were a bunch of examples, and the idea behind the A.SSE 3A, notice that I came back to these notes that I have right here many times, and that's completely fine and normal to do. So please make sure you take notes. I will post this in our resources, this PDF that I just made in our resources with all the pretty colors.